All right, I'm just going to make a quick video with this circuit simulation. I have an RC circuit already set up with a battery, resistor, capacitor. There are two switches here so that I can charge the capacitor with one switch and discharge it with the other. So I'll just let you see that process first. When I close the switch, current can flow out of the battery, goes into the capacitor, charging up this plate positively. Current leaves this plate, giving it a negative charge. But you can see that that only went on for like a couple of seconds because the capacitor is now at its full charge. Basically, it has the same voltage as the battery. Once these match, then it doesn't charge up anymore. So if I open that switch, the capacitor is now isolated. There's nowhere for the current to go. But if I close the bottom switch, then there's going to be this wire which connects the two sides of the capacitor, and that means it'll be able to discharge. So when I do that, current flows back out of the capacitor, returns to the other plate, and you can see that this last little bit of charge takes a lot longer to diminish than the other ones. And that's because of the exponential or asymptotic nature of the process. So I'm going to show you a couple of graphs. I can use this meter, maybe, to measure the voltage of the capacitor, for example. So right now it's just reading 0. But if I let the capacitor charge up, you can see the voltage of the capacitor also hops up. It's getting closer and closer to 10 volts. I don't feel like waiting an infinite amount of time for this video, so I'm just going to open up the switch, call it done. And then if I hit the discharge switch, we should see the voltage drop back down again. And there it goes. Initially, it's rapid, steep graph. It gets shallower and shallower. And eventually, that last plus and minus, there they go. Now I can also show you the current. I can put this current probe. This is one of those magical floating current probes. I can put it anywhere. So if I put it here, it should measure the same current that's flowing on this central branch of the circuit. So let's do a charge. You can see that the current sort of spiked and then is decaying down to 0. It's already basically at 0 because the capacitor is full. And then when I close the discharge switch, the current again is going to spike because at the beginning there's a lot of current as the capacitor empties itself. And then the current gradually diminishes as the charge dissipates. And the one other thing I want to demonstrate here is that I'm going to leave the current probe there. Instead of measuring the voltage of the capacitor, I'm going to measure the voltage of the resistor. And you're going to see a difference here. That's because the voltage of the capacitor depends on the charge Q, but the voltage of the resistor depends on the current, right? V equals IR for resistors. So when I charge the capacitor, whoops, I short-circuited my battery. Let me get that. When I charge the capacitor, notice that the voltage graph here, it spiked up and then decayed, which is exactly the same behavior that the current function displays. I can magically, instantaneously discharge the capacitor, so I'm going to do that so you can see it again. Here's the charging process a second time. Notice that these two graphs, they're doing the same thing, basically. And as I said, that's because the voltage for a resistor is I times R. So whatever that current graph in the corner is doing, if I'm measuring the voltage of the resistor, it's going to do the same kind of thing. So the voltage of the capacitor is now at 10 volts, but the voltage of the resistor is at 0 because there's no current. And if I discharge the system, although this graph got flipped, the same general thing is true, where it spikes to some initial value, just like the current, and then it decays to 0. So most of the time when people are asking questions about voltages in capacitor circuits, they're usually interested in the voltage on the capacitor itself. But be careful, because you may see questions where they ask about the voltage on the resistor instead. And the voltage for the resistor, again, depends on the current, not on the charge of the capacitor. So it's going to mirror the current function instead of the Q or V function. Okay, that's it for this.